Okay, so this problem, you're gonna wanna, with these absolute value inequalities, basically you can, I think this is algebra 1 situation, so that's why like kind of flashback for a lot of us, but you have 4 minus 2x has to be greater than 6, right? If this is true, then this works. But you can also have 4 minus 2x is less than negative 6. Now, this one's the one that's hard to write. But if you think about it, if they're less than negative 6, absolute value makes everything in it positive. So if it's negative 7, then yes, it's bigger than 6 because the absolute value will make it bigger than 6. So that's kind of how I wrote the second one. I think for this one, it was actually pretty easy. You just flip the sign, change the sign, and then flip this one. That's not underlined. I was like, flip this and change the sign. Have them both circled. But yeah, flip it, change the sign, and that's how you write the second equation. But if we solve this one, it becomes, I want to say, let's see, so you have negative 2x is greater than 2, so you then have x is less than negative 1. Remember, we have to flip the sign when we divide by a negative. Here you have 10 is less than 2x. I probably should have done these in different colors here. I have like a little border, so. And then x is greater than 5. So long as, oh my god, I'm sorry. No. Yeah. Okay, so my brain, oh my god. So long as you can grab a little thingy here. Negative 1 less, oh wait, my bad. Now we have to check to see if your answer is extraneous. So sometimes with these absolute value ones, with the whole changing the sign and everything, you solve for answers that cannot possibly make sense. So the way I like to check is I just take a value from here. So here, if we plug in, like, let's see, negative 3, and let's see if it works. So 4 minus 2 negative 3s, which is 4 plus 6. 4 plus 6, absolute value, 10, still 10, is greater than 6, so that works. You can definitely, on the real MCAS, I would recommend you do it on paper, not in your brain, because sometimes things seem one way in your brain, but on paper you're like, oh crud, I was wrong. And then for the second one, you have x is greater than 5. So let's see, let's pop in a 6 in there. So 4 minus 12 is greater than 6. What's 4 minus 12? 8. So, wait, 4 minus 12 is 8, right? Yeah, okay. I was just like, wait. Okay, so that also works. So, what you can do now is go to the real MCAS. Basically, I don't have, like, so remember, x is less than 1, right? And the sign was the shaded in bubble. How do you do this? I'm on an iPad right now. I have no idea how you do this. Oh my gosh. Remove. Okay, so you click that. Oh, okay. So that would be my final answer. Less than negative 1, but greater than 5. So shaded in is only when you have the sign that's like this. That's when you would use any of these shaded ones, but we don't have any of that, and we use an arrow because it's greater than in here, so they're not going to intersect. If it was like this area, then you would use segments like this whole, but we have 2 arrows, so we're not going to use those. But yeah, that's basically the gist. And so basically you just had to know to write this equation, which I know can definitely be hard. I'd say for the MCAS it should be simple enough where you're just flipping the sign and flipping it to negative. If it's on the MCAS and you're not sure, just plug in numbers. Be like 6. Does that work? 4 minus 12. Yes, 6 works. 5. Does that work? Oh, that equals 6. That's probably where a dot is, right? And it probably goes this way. So you can kind of like see with this whole number line, you could, if you were really desperate, just plug all the numbers in, figure out which ones work, and then do it. So that's an option. Not ideal, but doable.